Hello all, my name is Kuramarshad, and in previous video we have seen that artificial neural network have three basic or major components. Number one is input layer, second one was the hidden layers, and third one was the output layer. Now in today's video we will try to understand further working of artificial neural network with an example. So let me share my screen with you. To understand the working of artificial neural network, I have taken one example dataset over here. In this dataset, we have different features like age, heart disease, BMI, body mass index, glucose level, and the final output column, diabetes. Let's suppose these two records are training records and this record is for prediction. So we have a data set. Now try to understand, we have a data set having different features. Let's suppose this feature is x1, this feature is x2, this feature is x3, and this one is x4, and this is our final output. I am representing it with y. So agenda over here is to predict the diabetes. So I need to create a system, I need to create a neural network, I need to create a model that is able to predict the diabetes if we provide the following features to the neural network. So these features, age, heart disease, BMI, glucose level, will go inside the input layer. Here we will pass x1, which is age, here x2, which is heart disease, and here we will pass, let's suppose, x3, which is body mass index, and in the last neuron we will pass x4, which is body glucose level. Or on the basis of these four features we have to predict what output column. That is, 1 means patient has the diabetes, or 0 means no diabetes. When we pass these features to the input layer, let's suppose in age column we will pass 80. That is your first record I'm passing from here. This first record I'm going to pass now as an input to the neural network. So age neuron will get 80. Heart disease, only two things over there, 1 or 0. If 1 is present, then it means patient has the heart disease, and if 0 is present, then it means patient has no diabetes. So in case of first record, we have value 1 over here, means the patient has the heart disease. X3 body mass index is 25 point something, I think 19, and last glucose level is 140. This record will pass to the input layer, to the neural network, and in these lines we will define some random values. Let's suppose I have defined 0.8. Here in the second line I'll just defining 0.01, and in third line I'm defining 0.002. Let's suppose I have initialized 3 random values over here. These values are nothing but weights. These values are called weights of the neural network. This 80 will pass to the hidden layer. This value 80 will be passed to the hidden layer. But how it will be passed? I told you before that we will perform some kind of mathematical calculations in this region. So we will multiply this 80 with weight 1, that is nothing but 0.8. Then we will add 80 multiplied by 0.02, that is weight 2. Here weight 1 is 0.8, weight 2 is 0.02, plus 80 multiplied by 0. Let's suppose 001, that is weight 2, and this one is weight 3. So the summation of this product will be passed to the hidden neuron. Here inside hidden neuron we will have some kind of activation function. Activation function. Activation function is nothing but a mathematical function. Let's suppose I have written one function over here. Let's suppose activation function I'm writing over here, that is 1 over 1 plus e raised to power minus x. This activation function is called sigmoid activation function. Which function it is? Sigmoid activation function. So this function is responsible for finding out the relationship in between the data and also responsible to normalize the data. And this activation function will be present over this layer and in this layer. So each hidden layer will have an activation function. So we will pass the input to input layer. After multiplying that input with the weights, these weights are nothing but random values, random integers or maybe float values. And after multiplying or performing this mathematical calculations, we'll pass the value to the hidden layer. Each hidden layer will have activation function. Or these activation function are responsible for finding out the relationship between the data as well as to normalize the data. After finding these things, the information or data will be passed to the output layer. That will be your y hat. We will say it y hat. And we will get some kind of prediction. So in this case, we need to predict as a diabetes. So we need 1 over here. Maybe we'll get 0.3 over here. We need 1, but we are getting 0.3. Our actual value is 1, but our predicted value is coming as 0.3. So some difference is there. We want 1 over here because we have passed this record inside the neural network, and neural network is giving us the information or giving us the output 0.3, but actual output was 1. So some difference is there. This difference is called loss. We have to reduce this loss so that I will be able to get the exact or correct output. So this process of passing information from input layer to output layer is called feed forward network. Okay, so the process of passing information from input layer to hidden layer, then to the output layer, and getting the output and calculating the loss, this process is called feed forward network. In the next video, we will discuss about backward propagation, where actual learning happened. So in the next video, we will discuss backward propagation. So see you in the next video.